Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the creation of game utilities with our game map. In our last video, we had created an application which allows us to load a world map. This is done by the user clicking on a graphics control and then selecting the map of choice. This then displays in a larger graphics control the area of the map, which is sea, and the area which is land. And there is a grid superimposed upon that map to show the area of each of the territories. What we're going to do in today's video is we're going to create 50 rulers which are going to be positioned on the land portions of this map. They are then going to be animated as they move around the map and attempt to gain territory. Since we have gone to the bother of creating this map with its grid, onto which all this action is going to be animated, we don't want to regenerate the map for every single frame of the animation. So we're going to store the map as it currently stands inside a string variable. And we can do this in PowerBasic with a single graphics command. So let's have a look at the code. We're now looking at the rebuild map function. This is the function which takes our map array and creates the terrain map and draws the grid upon it. Once that grid has been drawn, we want to store the whole graphics map into a single variable. And we can do that with a single command, graphics get bits. This takes the graphic control, which is currently the attached one, and takes all the information on the graphics control and saves it to this string variable. We've designated this as a global string to allow it to be accessed from anywhere within the application. There is also a corresponding graphic setBits command to put that string back into the control. So we can do that at the start of each turn. So if we go back into the callback function where this rebuild map function was called from, we can see this is where the turn number is actually set. This is the initial setup of the map. What we want the user to do now is to click on the Process Turns button to enable the first turn to be executed, and in that first turn we will create and position all the rulers. So at the moment the Process Turns button is currently deactivated. So we're going to enable that here. We can do that using the Control Enable command, which takes two parameters, the first parameter being the handle of the dialog, and the second handle is the handle of the button we wish to enable. Following that, we're going to display the number of rulers on the screen by using the global variable, which is the long current rulers. So if we run our application now, we will see we can click on the world map, we can pick our map, and once the map is displayed, the Process Turn button is now functional. Therefore, our next task is to put some code in the event handler behind the click event of this button. So let's go into the callback function, the event handler. So here we are inside the callback function, our event handler for the Process Turns button. When the button is clicked, we want to process a turn. So we're going to have to create a new function whose purpose is to process a single turn. This is going to take three parameters, the first being the dialog handle, and the second is the handle of the large graphics control. The final parameter we're giving is the turn number. We're storing this in a global variable. And once this very first turn has been processed, we can test to see if the turn is now turn number 1. And at that point, we're going to be enabling the bulk turn button. So once the first turn has been processed, the user will then be able to click on the bulk turns. Currently, we have that set up to process 100 turns with a single button click. But we first have to create the Process Turn function, so let's do that one first. Our very first command in here should be to attach to the graphics control we're going to be using. So our three parameters, the one we're interested in is the big map variable. This is the handle of our large graphics map. So we're using a graphics attach command to instruct PowerBasic that all subsequent commands that are graphics related will be directed towards that control. Currently the turn number which has been passed in on the parameters list is a value of 0. This indicates that we have yet to process the first turn. As part of this first turn processing, we want to position and update the rulers on the map. So this is the first task. So we're testing the value of the turn number variable which has come in on our parameters. As this is 0, we want to first of all call a new function to position the rulers on the map, and the second to update the rulers on the map. So we will create the position rulers first of all so we can test that out. So this function takes no parameters. So we are going to be creating some local variables to allow us to step through each ruler using the long R variable, and to determine the coordinates that the ruler will appear on the map going into the X and Y variables. As I only want the rulers to appear on landmass and not in the sea, we're going to use another variable, valid, to say whether the position that has been selected is valid or not. So we're going to use a for next loop. This will step through each of our rulers, initially working out that the position I'm in is false, and while that is false, we want to determine our X and Y coordinates. And this is where the randomize command we set up at the beginning of the code is going to be used. We can use the rnd command to generate a value between 1 and the map width and 1 and the map height. The map width is 100 and the map height is 50. So this will give us an X and Y coordinate into which we can test to see whether that coordinate is sea or land. This information is stored in the map array, and we can use the mid $command to pick out the value in that string of that array. If the value is 1, then we have selected a land area. As I don't want two rulers to occupy the same territory in the first turn, we're going to refer to the owner map array. This is an array which has one element for each territory on the map, and this will tell us if the territory currently has an owner or not. So if the value is 0, then it's not currently owned, and our first task will be to set the owner to be the ruler we're processing. We're now going to be looking at the rulers array, which is an array of user-defined types. Just for clarity, I'm displaying here the user-defined type which we're going to be referring to. For documentation purposes, this is quite useful. So we now want to populate that rulers array. The X and Y coordinates are the position that the ruler is on the map. The power element is 1. This is the number of territories accumulated by the user. As this is the user just being positioned on the map, they only have one territory. And each ruler which is active has a 1 in the active element. So our 50 rulers will all be positioned on the map, be given the value of 1 for power, and they'll all be active. We can now mark this one as being valid, as we have positioned this ruler on a landmass. So the purpose of this function is to position all the rulers in the arrays. Having done that, we now have to position them on the map based on this data. So the next function we have to create is the update rulers on map. This will actually place each ruler on the map. So we'll want a small marker to show their position so we can see where all the rulers are. I've decided to make this marker red in colour. So again, we're going to be needing some local variables. And as you can probably guess, we're going to be doing yet another for next loop. So in order to give us some flexibility, just in case you wish to change the size of these maps, I'm going to determine the size of the graphics control based on what's on screen at this point in time by using the graphic getSize command. This will populate two variables, width and height. And then we will determine the size of the terrain boxes by dividing the width by the map width. So this tells us the size of each individual territory on the graphics control. And now we have to go through our for next loop. So this goes from 1 to the constant we populated for the total number of rulers, which is currently 50. We will at some point later want to put a rule in to remove rulers which have only a single territory. So this is a ruler whose empire is declining, but we'll leave that bit for now. Our first test will be to test to see whether the ruler is currently active or not. Once a ruler has been killed off, they will no longer be active. So we're testing the active element of our rulers array, If that equals 1, the ruler is active, and we can pick up their x and y coordinates. This is the terrain on the map they're actually currently in. Next, we have to work out where the coordinates are on the screen. So we've got a bit of arithmetic to do here. I want to display the rulers as basically circles, small circles in red on the map. So in order to do that, we're going to be using the graphics box command, for which we need to specify the top left and the bottom right coordinates. And we're going to use the graphics box command with our calculated coordinates, a value of 80 to make the box almost circular, and specifying two colours, in this case red, for both the colour of the circle and the surround border of that circle. So before we run our application, we'll need to test to make sure we've actually set up these new arrays which we're now accessing. So let's have a look at the PB main function. We have already dimensioned the map array. We have two new arrays, the rulers array and the owners of map array, so we'll need to set those up. So the rulers array is an array of a user-defined type, and the map array is a two-dimensional array of 100 by 50. So now that those arrays are set up, let's go back to the function which processes our turn. As we specified up here, to use a graphics attach command with the redraw option, in order to get the data appearing on screen to the user, we'll need to use a graphics redraw command. So we'll put that in at the end of the function. Without this graphics redraw command, the user would not see anything we have updated on the graphics control. So if we try running the application now and loading our map, and once we click on the Process Turn button, our rulers should be displayed. And there we have 50 rulers displayed on the landmass of the graphics map. So that is our very first initial turn with all the rulers in place. Our next task for turns beyond the very first turn is to work out the movement for the rulers. So now that we have all the rulers on the map, should the user click on the Process Turn button once more, we'll want to move the rulers. So we're going to create a new function whose task it will be to move our rulers around the map. Additionally, at the end of this function, we'll want to increment the turn number, to move the turn number on by one value each time this function is called. We can do that quite easily by using the increment command, which adds 1 to the variable that follows it. So our turn number is initially 0 and is then incremented by 1 to have a value of 1. We can then set the turn number on screen by calling the setTurnNumber function, which, as we did in the last video, will update the text control on screen. So let's now look at this new function, the one that will move our rulers. So this one is going to be a little more complex, as we're building in some rules and functions for the rulers. First, we'll have some local variables as before, and again we'll have a for next loop. As we did in the previous function, we're testing the active element of our array for rulers to ensure that the ruler is indeed active. Once a ruler becomes inactive, we will no longer move them or show them on the map. We will initially set the terrain to be C, which is an area into which we don't want the ruler going. And we'll create another loop, a while loop, to test to see whether the terrain is C or not. And we're going to have 10 attempts at moving a ruler. First of all, we need to work out where the ruler actually is on the map, and we can get that information by using the X and Y coordinates in the rulers array. Next, we have to determine the direction in which the ruler is going to move. This is going to pass back to us two parameters, a delta X and a delta Y. As the ruler is going to move one terrain space in any direction, this value could be either 0, 1 or -1 for each of these parameters. And to ensure a ruler will not wander off the edge of the map, which they shouldn't do, we'll test the value we're going to end up with for their X and Y coordinates. We'll come back in a moment and create the getDirection function, but let's push on from here. So now we know the X and Y coordinate the ruler will be moving into, we now have to determine the terrain type to see whether this is sea or land. So to determine the terrain, we're going to go back into the map array, pulling back the terrain type. If that value is 0, then the terrain we'll be moving into is C, so we can iterate the loop and attempt to move in a different direction. Next, we need to determine whether the terrain is already owned or not. If the terrain is not owned, then the ruler can move into that terrain and mark it as belonging to them. So we're testing the value in the owner map array. If it's 0, then it's not owned, so we can then update it to the value of our ruler. We can increment the number of territories the ruler actually has, and we can also populate the X and Y coordinates in our rulers array. Of course, there's always a possibility that this terrain will be owned by the ruler themselves. So if that's the case, we just want to move the ruler into that terrain. And the other possibility is that the terrain is owned by someone else. If that's the case, there's likely to be a battle to see who's going to own the terrain. But we'll cover that one later. So now that we've got to the end of that function, in order to test this out, we'll need to create the other function we referenced, which is the getDirection. This will be a very small function to return a random direction. This again uses the R&D command, giving us back a value between -1 and +1. If the value coming back for both the X and Y coordinates is 0, then that would mean the ruler is not moving from the terrain they're currently in. So we're running this while loop to ensure that the user will always be moving from the terrain they're currently in. So as we have now worked out where the rulers are going to move to on the map and updated the arrays, we now have to update the rulers on the map itself. As we've already created a function to do that, we can just paste this in as the next thing to do. However, we now want to redraw the basic map. As we've stored that in the game map global variable, we can now use the graphics set bits command to put the map back. So what the application should do now on the first turn after the rulers have been positioned is to move the rulers to another location. This updates the internal arrays. Then we restore the game map to its pristine state of just the bare terrain and the grid, and then we update the rulers on their new positions on the map. So if we try running the application now, select our map, and click the Process Turn function. We can now see that the rulers have been positioned on the map. If we click Process Turn once more to move to turn number 2, we can see that the rulers have indeed moved. If we click it once more, they have moved again. So our function to move rulers around the map appears to be working quite happily. And the turns keep increasing. So in summary, what we've achieved today is we have generated 50 rulers. We have positioned them on the map, and we now have a nice little animation going each time the user clicks Process Turn. The rulers decide in which direction to move and move in that direction. While the arrays in the background are being updated to see which territories the users are controlling, we're not displaying anything on the screen to indicate which territories are actually owned by which rulers. But we'll cover this in the next video. Plus, the battling between rulers to see who's going to win. However, that's it for today. Thank you for watching.